Welcome, everyone. Hopefully you can hear me okay. My name is Brad Schmidt. I'm the Global UAV Sales Manager here at Applanix. Today I'm joined by River Kim, a Product Support Analyst from our Customer Support Department. And also I've got a couple of my colleagues online, Cynthia and Sarah from our Marketing Department will help us with some of the logistics if we need some support along the way. So today our webinar is on Applanix POSPac training. This is the 5th webinar that we've had over the course of the AUVSI conference, and we're very excited to have brought you this whole series of capabilities. And if you haven't had a chance to see some of the earlier webinars that we put on, we are going to make those available on our website, and you'll have access to those at a later time here, so that you'll be able to go through them on your own. So a couple of things just on the logistical side. Everyone is currently on mute, but if you do have questions as we go through this, please enter them into the, I believe either the chat or the questions box, whichever form you have basically in your screen. You can use that to enter questions along the way. We will basically take those questions at the end of the webinar. Now, this webinar is going to last about 45 minutes. So we've got some content in terms of what POSPac is, and then we're going to actually take you into a demonstration of the software so you can actually see how it works. Now, the POSPac software basically is our post-processing software for UAV data. So that is what the focus of our current webinar will be for today. A couple of other things. If you do have questions after this, we're going to have some time for questions at the end, about maybe 10, 15 minutes max for questions. But if there's further things you would like to talk to myself or any of my colleagues about at Applanix, you can also book an appointment for meetings at the AUVSI conference. And to be able to do that, if you go to our website, applanix.com, you'll actually see the registration information there. It comes up pretty quickly once you access our website. So I think that's a bit of some detail with respect to our operational parameters for today. And I think on that note, since we have some material to get through this morning that we want to cover off, we'll just go to our presentation. Now, what we've done for the presentation is we've actually pre-recorded this. So this is a recording, although the original, for example, myself and River Kim are on the recording. So we've actually just pre-recorded this, but we're here today and we'll basically take your questions at the end of this particular session. So we can then address any items you may want to at that time. So I think without further ado, I'm going to ask my colleague Cynthia to basically start the video, and we'll begin the presentation now. I want to welcome everybody as well to this particular training set. So this is going to be training on POSPac UAV, and what we're going to do is we're going to take you through some slides, and we're going to introduce the software to you if you're not familiar with it, and then we're going to actually go through an actual demonstration of the software to show you how it actually works. So if I could have the next slide, please. So what I want to do is, first of all, start off with the two different flavors of POSPac that we have. So we have something called POSPac MMS, which I'm going to talk about in a moment, which is our primary POSPac tool for all the different business units that we have at Applanix. We also then have our POSPac UAV software, which is specifically for the UAV industry, and this is what we're going to be focused on today. So we'll basically walk you through what POSPac UAV is and some of the value and differentiators that it has. And then we'll get into a demonstration of the software as well as a final wrap up. And we'll talk about next steps once we complete the presentation. Next slide, please. So let me start off with POSPac MMS. So basically this is our primary POS processing tool. It basically serves to support our airborne industry, our land our land autonomous industry as well as our marine industry. So it's a robust piece of software that has been around for quite some time and does an absolutely excellent job in terms of processing the GNSS data, the IMU data, the image data, et cetera, that we have associated with these various industries. And so it supports various processing modes. It supports basically single base, so working from a single base correction solution or working from a virtual reference solution such as smart base. We're going to talk about a little bit about Trimble's PPRTX solution, which is another solution for correcting data, as well as the POSPac MMS supports multi-single base solutions as well. So this is software that you may have seen or heard of, but basically the difference between it and the POSPac UAV software is that POSPac MMS supports all of our different industry segments, whereas the POSPac UAV software is a subset of POSPac MMS designed specifically for the UAV industry. So on that note, we'll move to the next slide. So it's a GNSS aided inertial post-processing software. As I say, it's a subset of POSPac MMS, and basically it works with three different correction solutions, either working with a single base station, working with a Applanix smart base, or working with the Trimble Centerpoint RTX solution. So that's what it works with. And now we'll basically move on to the next slide. And this is really where the POSPac software fits in. So this is the entire workflow represented on a single slide for you. So we have the UAV rover, which is out collecting data with the integrated GNSS IMU unit on the sensor payload. That works in conjunction with the GNSS satellite constellation, as well as, in this case here, we have a single base station. And the single base station that's illustrated in this particular slide is the Applanix GNSS smart target, and basically what it is a GNSS receiver that is surrounded by a target that can be picked up either in imagery or in Lidar data and used as a checkpoint. So once the data is collected, that would be the GNSS data, so your GPS data, etc. That's your positional data, along with your INS or your inertial data, which is provided through the IMU, which provides orientation information, along with your corrected data or your correction solution data. That all feeds into POSPac UAV. And then POSPac UAV processes all of that data along with the imagery and then generates a number of different file types, such as an exterior orientation file in the case of, say, for example, RGB imagery, or an SBET file, which is a smooth best estimate trajectory file. We can even produce a LAS file for Lidar data, which then you can take into any number of different applications and be able to produce kind of final deliverable products in those other solutions. We have our own solution too, something called the UAS Master, but these output file formats are pretty much industry standard and can feed into any number of different software solutions for producing information products. Next slide, please. So this is how it works. So as I say, it basically, the inputs are the raw GNS inertial data, along with the correction data and the imagery. We all feed that into the POSPac UAV software, and then it creates the solutions. So one of the things you're going to see with POSPac UAV, a lot of it is just checking to make sure that the data that has been collected is indeed correct. And once you confirm the accuracy of the data, then basically POSPac pretty much processes the data automatically. So, and we're going to see how this works in just a few minutes when River starts taking over the presentation and gives us a demonstration. So if you could move on to the next slide, please. So some of the benefits of POSPac UAV. Well, I think one of the key things is that this particular processing solution has been refactored from our POSPac MMS software. It has been proven in our manned airborne segment, and as well as some of the other segments that we have. So it's a very robust solution for processing UAV data. It helps to improve accuracy even in poor GNS environments. It offers a forward and reverse processing to kind of fix any kind of data gaps, as well as it is a time and cost saver. I mean, one of the things that POSPac UAV offers over other solutions out there in the market, such as using aerial triangulation or even a PPK solution, is that because we're collecting both the orientation data and the position data, we have all the information to process the data automatically to create a final directly georeferenced solution that we can then use. We're not looking at kind of tying ground control points to the respective corresponding orientation in their the relevant imagery, or having to use kind of ground control points as we would in a PPK process. This is very effective in terms of being able to process the data very quickly. So you can land your UAV platform very quickly, get the data into the POSPac UAV software. You can even run on a laptop in the field, and you can start processing your data and turn it around very quickly. So that's one of the key advantages. And then I think some of the other advantages are the fact that we support the virtual reference solutions or virtual reference stations for processing without base stations, or our own PPRTX service, the Trimble PPRTX service. So those are some of the key benefits that we like to highlight with respect to the POSPac UAV software. You can have the next slide, please. So the POSPac UAV software has a couple of add-ons. One of the key add-ons is the UAV Lidar bore sight calibration tool, which is basically an add-on into the POSPac software, as well as the UAV Lidar trajectory adjustment module, which also is an add-on. So the trajectory adjustment module does both bore sighting calibration and the trajectory adjustments. So these are a couple of add-ons, and of course, through these add-ons, you can they come with the capability to generate LAS files, which really allows you, in the case of LiDAR, to visualize the data within one solution, within the POSPac solution. So if I can have the next slide, please. So I did mention that in addition to a single base station, it supports Applanix Smart Base, which is a virtual reference solution. And basically, if you have a CORS network in your area, you can leverage that through Smart Base to actually have a correction solution for your UAV data without actually having a physical base station. So that's the advantage of Smart Base. The issue with Smart Base, though, is that you have to request the solution over the internet, and it can take up to 24 hours to get that that correction solution over to you, and as a result, there's a bit of a delay in terms of processing, which is not the case, say, for example, with having a physical base station, or even with the PPRTX software, which we'll talk about next. So if I could have the next slide, please. So, and the other correction solution that works with POSPac is, as I say, is the post-processing RTX solution, and it tracks virtually all of the different navigational satellite networks out there. It's a very robust solution. It works very well. It works over the internet as well too. You can basically connect to this solution. It takes about between 15 and 30 minutes convergence time in most areas around the world, which is maybe a little bit long for flying UAVs, but there are a number of regions right now that have something called PPRTX Fast, which allows for the initialization of the software or the convergence of the software within about 5 or 10 minutes, which is quite respectable for using with UAVs. The only issue there is that with the PPRTX Fast is that it's not available everywhere in the world, at least not yet. But this is the network that continues to be built out as time goes on and becomes more robust and substantial as we continue to add to this overall network for correction technology. And next slide, please. So this is basically how the POSPac RTX solution works. Basically, you take your trajectory information and input that into the RTX server. It provides the corrections, processes the data, etc., and then it outputs the position and orientation data needed to basically provide or to support the correction services within POSPac UAV. If I could have the next slide, please. Okay, so on that note, what I'm going to do is turn it over to River, and River is going to walk us through a little bit more explanation with respect to POSPac UAV, and then she's going to walk us through a demonstration, so you'll actually get a chance to see how the software works. And then after River finishes up, we'll come back, we'll take any questions that may be outstanding, and we'll talk about next steps after this for our resellers.
All right, so I'm going to be giving a presentation going over the software licensing aspect of POSPac. Then I'll go over the standard workflow for POSPac, some tips for new users of this software, and even people who have already tried using POSPac may not be following these standard pre-checks and post-checks of the process trajectory. And then at the end of my presentation, I will be giving some sample data sets. Based on the amount of time that we have left, I might just show 2 of them, but we'll see about this. All right, so Brad did touch on the differences between POSPac MMS and POSPac UAV. So with POSPac MMS, this allows you to process data from all Applanix hardware. With POSPac MMS, the base license that you purchase, this includes smart base processing. The difference with UAV is that the base license only includes single base processing. If you do want to use the smart base feature, this will have to be purchased separately as an upgrade. So the software license utility is the license manager that you'll use to activate and deactivate your license. Activating a license requires you to have an entitlement ID, and each activation is locked to a specific locking code. Now you'll see in the bottom right corner of the software license utility, there's 2 locking codes. With our latest release, we made a change to the locking code so that it supports dual locking codes. And these are generated based on the CPU information from the motherboard, as well as the Ethernet MAC address. So right now, in terms of virtual machines or cloud servers, it's not fully supported yet because the locking codes are tied to the physical hardware of the computer. Now, with the software license utility, any client computer on the network can access the license from the license server computer. Now, moving forward, I'm going to describe the license server computer as the computer where you've activated the license, and the client computer is basically any user on the same network. So the software license utility has several features that may be useful to you and your clients. The checkout feature is one that's oftentimes used, and it allows a client computer to check out a licensee to take outside of the network for up to 90 days. This license can be checked back into the network at any time as long as you're connected back. And then after the duration of your commuter license, the license will automatically check back into the server. We also have a remote version of the checkout feature, and this allows users to check out the licenses on a computer that doesn't have direct access to the license server. We also have manual activation and deactivation options available for customers who have very strict IT security on their network. I have encountered some customers who have license servers that don't have internet access. And if you don't have internet access, unfortunately, you won't be able to use the automatic activation and deactivation. So this will have to be done manually. All right, so in terms of POSPac workflow, Brad also did touch briefly on the workflow of POSPac. So we start off with our inputs. So just for the base typical workflow, we have our raw APX data. We have our raw base station data, if you have that. We're going to import that. And then we can use the Find Base Station tool if you want to use Smart Base or need to import a single base station. Then we move on to the GNSS inertial processor. And then from there, we can choose to export our process trajectory into an ASCII format or a binary navigation file. You can also export it so that you have your SBET .out file as well. So I did want to go over some habits that I think is useful for users of POSPac. And oftentimes these steps are skipped, and a lot of times customers just import their data and then just press the process button. But it's very important that you check your imported raw data and the generated log files. So as soon as you import your raw data, there's message logs that are available within POSPac. And some important ones here are the TO4 data import and the IMU data continuity checking message logs. So the TO4 data import is going to tell you information about the system, what model it is, the serial number, what firmware version it is, and it also includes the list of the lever arms and mounting angles that have been input through the web controller. So checking display plots is also important for your raw data. We want to verify the real-time accuracy and identify whether the system applied any resets. And resets can be identified at sudden accuracy drops. So the real-time performance metrics are very useful. We can look at these error RMS plots, and if there's a sudden spike, that usually indicates that there has been a reset to the navigator. We can also verify the satellite visibility and confirm that there's clean GNSS observables by looking at the primary satellite data plots. So this is what one of the plots looks like. This is the GPS and GLONASS L1 satellite lock and elevation plot. So this plot addresses the satellite visibility as well as the elevation angles for each satellite vehicle. The cycle slips are indicated by the black cross markers. And if we look at the L1 plots, we want to make sure that we also look at the L2 plots, and there should be a similar number of satellites for both. The SNR plots can also be looked at to make sure that you have the right values for your SNR for L1 and L2. Now for SNRs for L1, we want to see the majority of the signals between 35 and 53 decibels. And for L2, these values are typically about 10 to 15 decibels worse. So when we import user base stations, after you import it, you want to right-click on the base station and click Set Base Station. And when you do this, POSPac will automatically run a QC on that base station to make sure that there's good coverage and that it covers the entire time of your rover data. Now, if you're unsure about the coordinates of your base station, you can use the Compute RTX coordinate feature within POSPac. And what that will do is it will use the Trimble Centerpoint RTX technology and refine the coordinates for your imported base station. And also Brad mentioned that we do offer the Smart Target base station at Applanix, and it's a low-cost survey-grade GNSS base station, which you can also use as a photographic GCP. So if the user doesn't have their own base station available, we can use the Find Base Stations tool to automatically download and import nearby base stations from the available GNSS services. You'll be using this for single base or smart base processing. And keep in mind, you do need an internet connection to use this tool. When you plan your survey, you should keep in mind that the proximity to a single base station or a network of stations should be considered, as the solution accuracy will decrease the further you are from a station. So I just wanted to quickly go over the different processing modes that we do have in POSPac. And the most commonly used ones will be single base and smart base processing, as well as PPRTX. We do have some other options here, the multi-single base. We have inertially aided PPP, which is another mode that you can use if you don't have any base stations available. However, with the IAPP processing mode, you will have to wait about 14 days for the precise ephemeris files to become available. All right, so once you've completed your pre-check on your raw data, we can now move on to selecting the desired processing mode. After you process, new log files will be generated for the forward, backwards, and smooth processing modes. If you do run into a processing failure, we recommend that you investigate the log files, specifically the forward processing log files, and that will usually tell you at what point in time the failure occurred, and it'll help you isolate the problem. Now, after you've completed processing, it's important that you also do a post-check of the process trajectory. There are some plots that I recommend that you review. So some of these include the solution status plot, which will show you the ambiguity resolution over the GNSS time for the forward and reverse processing. So for APX applications, the UAV is typically flown in very clear skies. So we would expect that the processing mode for the majority of the flight will be fixed. It's a little bit hard to see in this plot here, but on the y-axis, there's numbers, and each number is indicating what processing mode is being used. So for 0, that's fixed mode. For 2, that's float. So in this case, we have the majority of the flight at 0. And just to give you an example of what this same plot would look like for an LV application. So in this case, for an LV application, we're going to see frequent processing mode variation due to bad satellite coverage. So tree canopies, going under tunnels and bridges. So in this case, we would expect there to be lots of variation. So another plot that I find is very useful to review is the SBET ICAR separation plot. And this plot illustrates the 3D difference between the forward and backward processing. And it's a very good indicator of whether the ambiguity for both processing directions are identical or not. So what we want to see are differences that are very, very low values here. And here you'll see, actually it's probably hard to see, but it's around, floating around 3 centimeters, plus minus 3 centimeters. So for unmanned airborne applications, the lever arms are typically obtained from existing CAD models. So most of the time, your lever arm measurements and mounting angles will be very precise. But in the case that you don't have very precise measurements, you can use the calibrated installation parameters plots to validate only your reference to primary GNSS lever arms. And I'll show you how to validate that in the next slide. But once your GNSS lever arms are known and validated, we do recommend that you keep the lever arm values fixed and change the standard deviation in your POSPac settings to 3 centimeters or less for your future missions. So that's only if you're 100% sure that your lever arm measurements are good. So in the case that you do want to validate your lever arms, this is the Y reference to primary GNSS lever arm. And what we will do is we will compare the difference between the a priori lever arm, so that's at the very beginning of this plot, so that's the value that you've entered, and compare it to what POSPac has calibrated, so at the end of the plot here. And if this difference is greater than 10 centimeters, we do recommend that you apply this new lever arm back into your project settings and process it again. But keep in mind that if your other lever arms and mounting angles are not accurate, then this plot will not be as good of a tool to use to validate your lever arms. And another plot here that's very important to look at is the smooth performance metrics. So this is going to be your position errors for your final solution in POSPac. So we have this for the north, the east, and the down position errors. So I did want to touch lightly on the Lidar QC tools. And the Lidar QC tools is an optional software module that is a part of POSPac. And as Brad mentioned, there's 2 options for it. There's one that lets you do Lidar bore site calibration only. And there's another option for Lidar bore site calibration plus trajectory adjustment. Now, what does the Lidar QC tools do? What it does is it precisely estimates the bore site misalignment angles between the IMU and the Lidar frame. And the Lidar QC tools right now supports 2 Lidar formats. So that includes the Velodyne PCAP format and the generic format, which includes 5 doubles. That's time, X, Y, Z, and intensity. So in order to use the Lidar QC tools, we do have sort of a strict requirement for it. And these requirements will ensure optimal bore site and trajectory correction accuracy. So this includes refined and optimal mounting angles and lever arms. You have to set your lever arm standard deviations to 1 centimeter. You will have to have good GNSS quality, terrain with lots of distinct features such as buildings, and we do recommend optimal flight patterns of 4 parallel lines flown in opposite directions and 2 perpendicular lines. Now keep in mind that the bore sights will be stable as long as the IMU is hard mounted to the LiDAR. So the Lidar QC tools is able to directly output LAS files that apply these bore sight and refined trajectory information. But if you are using an external software to bore sight and refine the data, POSPac does offer multiple output options to export the SBET file. So with the export tool, we have the default ASCII format available. So you'll see here in this picture, the blue icons are what comes default within POSPac, and we do allow users to create their own custom export profile. So if there's a specific output format that you need, you are able to make your own template for this. So this is what that will look like when you edit your own profile. You'll be able to set your own header, your own data record types, and footers for export. And your exported files will be found in the export project folder. And the SBET is actually located in the proc folder. And I'll show you these after we go through some of our samples. And I did also want to mention the QC report feature in POSPac. And what this does is this allows you to generate a summary report of your process data in PDF format. And this report includes many of the plots that we just described, as well as additional information like mission information, hardware, the raw data QC, trajectory information, and many more. And this is useful if you want to share the results of your collection and processing results with someone who may not have POSPac readily available to review the data itself. All right, so that's it for the presentation part. I will be going over 3 data sets. I think I'll have enough time to go over all 3 of them. We're going to start off with an APX15 data set, go over just the basic workflow, the pre-check, processing, and post-check. And our second data set will be an APX18. And for this one, I'll just show you the differences in the settings. So for the APX18 data set, the Lidar QC tools typically takes a long time to process, so I won't be demoing the actual process of doing it, but I can show you the results of it and show you where the files are located. And then our last data set will be an APX20, and I just wanted to show a comparison of 3 of our main processing modes, as well as the coordinate manager, to how to use the Centerpoint RTX to refine your base station coordinates, as well as the differences in the settings if you have an external IMU. All right, so if anyone does have any questions, now would be a good time because I will be pulling up these data sets.
So just while River is doing that, there's a couple of things that we're going to do here. Is that I just want to mention that we do have more information in the reseller portal about using POSPac UAV. There's some additional videos in there as well too. So just keep that in mind as a resource for you going forward. And we'll also put this video in the reseller portal as well. And River's going to pass this along to you as she's already mentioned. So back to you, River.
All right, thanks. Can you just confirm that you see the POSPac window in the sharing screen?
Yes.
Okay, perfect. All right, so I just have a blank project open here. So before I even do anything, I'm just going to save the project first, and I will save it in the same folder where my raw data is. And I'll call this D1 APX15. All right, so once I've saved the project, now I'm going to move on to the import step. So there's 2 options for importing your data. You can either drag in the data or you can use the import tool that's within POSPac. I find that just dragging the files in is a lot easier. So I have my TO4 from the APX. I'm going to drag it in here. It's going to be extracting this rover data. And what it does is it also automatically downloads any additional ephemeris data that's available online. So it will ask you in the beginning after you import to select the antenna type. Based on the antenna type that you have, you will be able to select it here. This data set, I'm not 100% sure what the antenna was because this was collected a while ago. So what I'm going to do just for the purposes of this demonstration, I'm just going to press OK and leave it at unknown external. If you leave it at unknown external, it's just going to use a generic model for the antenna phase centers. All right, so here's what the APX collection looks like. We can see that some events have been taken, and you can also disable the events, just only see the trajectory if you go to view and click event 1. And that's going to disable the events from showing up. Okay, so with the pre-check stage, I'm going to be looking at the message logs. So I'm going to go to reports, message logs, and here I'll scroll down to the TO4 data import message log. And for the TO4 files, they're not as descriptive as our standalone systems, such as the micropause. So for the TO4 data import, it's usually only going to just give you information about the unit itself, the different lever arms and mounting angles that you have, as well as information about the different ephemerides and observables. So next, I'm going to go to the IMU data continuity checking. I want to make sure that there's no time tag anomalies. I want to make sure that there's no data gaps. So this is all good here. Now that we've checked those two message logs, I'm going to open up the display plots. And these are the display plots that are available right after you import your raw data. So the plots that we mentioned, let's review the performance metrics display plots. So we'll go to real-time trajectory reference frame. Oh, actually, sorry, we'll go to performance metrics here. And we have the Norse position error. And if you press Shift, you can actually highlight multiple graphs, right-click, display selected, and it lets you view 3 of these plots overlaid on top of each other. So here we have the performance metrics of about 30 to 50 centimeters for north, east, and down. Next, we're going to look at the satellite observables. So that's going to be under primary GPS GLONASS satellite data. Let's look at the satellite lock and elevation. So this looks really good here. We don't have too many cycle slips, which is good. And if you do expand the satellite lock and elevation, you can look at both L1 and L2 separately. Now we can look at the SNR values, which is going to be under primary GPS GLONASS observables data. So if we scroll down, we have GPS L1 SNR. So in my presentation, I mentioned that the majority of the signal should be between 35 and I believe it was 58 decibels. So that does seem to be the case here. And I'm just going to double check that for the L2 as well. And for L2, it's going to be about 10 to 15 decibels less. So this also looks very good here. So I'm going to just close these up here. If I open the real-time trajectory, it allows me to view the top view of the entire collection. And sometimes I do like to compare the top view with the primary GNSS navigation data. The primary GNSS navigation data has the same plots, has similar plots to the real-time trajectory. The only difference is the primary GNSS only includes the receiver data. So if there's a problem with some of your other sensors, if there's a problem with your IMU, if you compare the two plots, top view from real time and top view from primary GNSS, you can immediately know that there's a problem with maybe the IMU combining all this information together. All right, so that's our pre-check for the rover data. I'm going to now import the base station that I have for this data set. The base station is in TO2 format, which we can automatically just drag here, and it will extract this information. All right, so I don't know if you can see this. Can you just let me know, is the white color better for you to view or is the black color better? Now, sure, Brad.
I think the white color shows up a little bit better. Well, maybe
White's better?
not. Yeah, well, it's hard to say.
Okay.
Yeah,
I'm just gonna leave it as
yeah,
black.
yeah, that's
I'd go
fine. I
with
mean,
white.
Oh, white, okay.
I'd go with the white. It
Okay.
gives a better contrast.
All right, so here we have the base station and it's connecting the baseline to the very beginning of our collection. So if I go to the Project Explorer, that'll be under View, Project Explorer. And if I open this up, it'll go to the base station. It'll list all the base stations. I can either right click on the base station in this list, or you can right click on the base station in the actual plan view. But I find it's easier to just use the project view. So I will press Set Base Station. I'm going to be using single base processing in this example. And if you're importing your own base station, you have to make sure to press Set Base Station first. And once you do this, it's going to go through a QC process. With the QC process, it tells you how much of the base station is fixed compared to your solution, and you want to see a high percentage of fixed. So now that we've set our base station, we've done our pre-check, I'm going to move on to the GNSS inertial processor. So here, because I've set my base station, it automatically selects single base processing. Next, I'm going to press the Run button. So here's, it went through the forward, backward, precise, and now the last step is the smoother processing. So when you look on the plan view, you'll notice that there's two colors on the screen. The pink is the real time and the green is the post-processed. So now that we've done the processing, let's move on to the post-check. So I want to review the message logs first. Because we didn't have any interruptions to the processing, there was no failures. It's not necessary to look through these message logs, but just for your information, this is the forward processing message logs, and it basically tells us information. So I'll look at the display plots next. And let's start off with reviewing the solution status plots. So that'll be here. You will notice that there's significantly more plots available after you process. So for the processing mode, for the entire flight here, for the entire processing time, it is fixed, which is very good. Next, I'll look at the SBET ICAR separation. So here, I'm going to select all three and display them. And at the beginning and ends of the flight, it's okay if it's a little bit higher. That's because the system is initializing in the forward processing at the beginning, and for the backwards processing, it's initializing at the other end. What we want to look at is the middle of the collection here, which is all under about 1 centimeter. So this is very good as well. We can now look at the calibrated installation parameters. So for X here, the difference from what we've input and what POSPac has calibrated is around 2.5 centimeters. So this isn't that much of a difference. So I'm okay with this. And same with the Y, it's under 10 centimeters. And same with the Z, it's under 10 centimeters. Okay, now let's compare the smooth performance metrics. So this is going to be the position error RMS values for our process solution. And if you remember, for the real-time performance metrics, we had about 30 centimeters for the real-time. So here with the processed, we have just under 2 centimeters for our north and east position. And it's always the case that the down position error will be a little bit higher. And that's just how the satellites are being tracked. All right, so now I'm going to show you the export tool. We've completed our post check on some of these display plots. So if we go to tools and you go to export, this is the different options you have for the export. and I'm just going to choose the default ASCII format. So here you can choose if you want to use export your post-process solution or your real-time solution. And if you click export, you can find this exported data within the mission folder. So the mission folder is going to be the same name as what you named your POSPac project. And then you go to mission 1, and then we have export, and these are your ASCII files. Now, if you did want to get your SBET, I mentioned you have to go to the proc folder, and the proc folder will have the SBET file in it. So that's right here, SBET mission 1 out. I also did want to show you the QC report. So QC report is under reports, QC report, and then we have diagnostic here. If I generate this, it's going to generate a PDF. All right. So that's right here, report mission PDF. So if I open this PDF, you'll see there's a lot of information here that's very useful if you want to send this over to someone on your team, send this over to a client. It also has all the plots that we just went over as well. All right, so that's just the first data set that I'm going to show you. Next, I'm just going to show you quickly the APX 18 data set folder. So the mission folder is going to be the same name as what you named your POSPac project. And then you go to mission 1, and then we have export, and these are your ASCII files. Now, if you did want to get your SBET, I mentioned you have to go to the proc folder, and the proc folder will have the SBET file in it. So that's right here, SBET mission 1 out. I also did want to show you the QC report folder. So the mission folder is going to be the same name as what you named your POSPac project. And then you go to mission 1, and then we have export, and these are your ASCII files. Now, if you did want to get your SBET, I mentioned you have to go to the proc folder, and the folder. So the mission folder is going to be the same name as what you named your POSPac project.
Okay, so that is basically a quick introduction into the POSPac UAV software. Right now, if you have questions for River, would be a good time to enter those questions in the question box, and we'll start to go through those. Okay, a couple of other things here. I just want to let you know that we did mention in that video that there was sample data being sent out, but that was specifically for our resellers when we did this earlier for our resellers. However, if you're interested in a POSPac UAV evaluation license and a data set to test it out with, you can certainly get in touch with myself or any of our UAV team at Applanix, and we'd be happy to help you out with that. My particular contact details are bschmidt at applanix.com. That's BSCHMIDT at applanix.com. I can help you out with an evaluation license if you're interested in that. And my contact details are also on our contact page on our website. So if you didn't get all that, it's available there. So anyways, let's see what else I have here before we take questions. Yeah, so one of the things we did was just kind of cut this presentation a little bit short just so that we can honor the 1 hour time frame that we had reserved for this webinar. And we did want to give some time here at the end for a few questions. So Cynthia, are there some questions that have come in?
Yeah, we have a few here, Brad.
All right, yeah, I can take over that here.
Perfect.
So we do have a few questions here. I'll just start off reading the first one. So our first question is, what exactly is contained in the POSPac LAS output? So for our point cloud output, that will be a .las point cloud format. And this can be viewed in third-party point cloud software. The Lidar QC tool itself provides the estimated calibrated values for bore sight misalignment angles between the IMU and the Lidar. And with that Lidar QC tool, you have the option to create that standard LAS file format for point cloud visualization. Our next question here is, can cycle slips be edited out of a dataset to improve processing results? That's a really good question. Well, cycle slips are actually a lack of GNSS observables. So essentially, you can think of it as a data gap. So unfortunately, cycle slips cannot be edited out of the raw data, and the processing, luckily with POSPac, is able to work around these cycle slips and still give you a very good solution. Now, problems can occur if you do see an excess of cycle slips, and that's when you would have to look at those message logs to determine where the processing is having issues. There are options. For example, if you did have a power outage during your survey, if, for example, the middle of your flight, there's actually a power loss, there are still ways to salvage your collection by processing that flight in two components. So within your POSPac settings, there's options to set your processing time, and you can set it so that it processes just before that data gap, and then open up a second project and process after that data gap. And that might be something that you would do as a worst case scenario if that flight cannot be flown again. Another question we have is, my display plots have never allowed me to use select and display more than one chart at a time. Is there a quick fix or a suggested step to allow to display multiple plots at once? Well, with the display plot viewing function, typically you can only view display plots on top of each other if they're within the same display plot group. You also need to make sure that the axes are the same for the plots that you're trying to overlay on top of each other. If you are having issues with displaying the plots similarly to what was done in this presentation, I would suggest that you contact our technical support group, and they would be able to help you out with troubleshooting that. And their email is techsupport@applanix.com. There was another question asking about if this presentation will be available. I believe this entire webinar was recorded. So the recording of this webinar should be sent to all of our attendees. Is that correct, Cynthia?
Yeah. Yes, that is correct, River.
Okay, perfect. So you'll get this entire webinar sent to you by email once this is over. If you are interested in reviewing that full training video, we'll probably be sending out information on that later. I don't know how Cynthia will be organizing that, but it will likely be via email if you're interested.
Yes, that's correct. We're going to be emailing out recordings for all the sessions, so all 5 sessions for AUVSI Xponential this year, and you'll likely be receiving that either Friday or early next week.
Perfect. How is it possible to get a trial license? That's another question that just came in. So if you would like to get a trial license, I would suggest to contact Brad. He mentioned his details, and Brad's contact details can also be found on our Applanix website. So please contact Brad if you're interested. I'm sure we can organize a sample dataset similar to the one that was shown in this video if you do not have a system yourself.
Yeah, just on that, if I could just jump in there. So basically, POSPac UAV works with our GNSS IMU technology. So it's designed to work with the Applanix hardware for direct georeferencing. So if you are actually flying a sensor that has the Applanix GNSS IMU on board, then you'd be able to process that data set with POSPac UAV. If you don't, and you're just interested in looking into more of the functionality of what POSPac offers, then I can arrange for that. We can arrange for that evaluation license along with a sample data set that you can try it out and start to understand a little bit more about how the software works.
Yeah, Brad, I also wanted to mention for that Applanix hardware, the data format is actually going to be .to4. So if you do have a system and your outputs include that .to4, you should be able to import that into POSPac software.
Yes.
Yeah, that seems to be it for the questions, Brad.
Okay. Okay, then I think we're pretty much on the hour that we had reserved for this. So I want to thank everybody for taking the time out of your day to spend with us, and we really do appreciate that. And as I say, or as Cynthia mentioned, we'll get the recording out. And also, if you're interested in an evaluation license, please let me know about that as well. Once again, thank you very much, and have a great show. Have a great day, and hope to hear from you soon. Thank you. Bye-bye.